z squared, then EV over what? Over n. Alright, over n squared. Okay, so you can use any of those two formulas to calculate for energy and for radius, alright, of an atom. So you can use that to determine it. Then your change in energy, alright, is equal to the excited energy minus the ground state energy, A1. Okay, you must also note that. So this one is for determining the radius of the atom. R is equal to n squared over z. Your n is number of shell, alright, represented by the element. I'll take one question on that. Z is the atomic number. R0 is called the Bohr radius. Bohr radius. Of course, we know that when we have energy to be E is equal to minus 13.6 EV over n squared, alright, our EV, 1 EV, alright, if you need to convert, is equivalent to 1.6 times 10 raised to the power minus 19 joules. Alright, that's 1 electron volt. Okay, so this one is for radius, while this one is for what? It's for energy. So now let's look at how we can apply those things in a question. Now, if you are to determine the energy, alright, or the radius of what? Of an atom, how do you calculate for it? So I'll take one question from this end. Okay, so the first question I have here says that calculate the radius of Li2 plus. Okay, or let's say calculate the radius of He plus or He. Let's use He plus. Calculate the radius of what? Of He plus. This is the question. So how do you calculate for the radius? What does say radius is? Radius is given to what? Number of shell square over z all into what? R0. And I said R is the radius of the atom, n number of shells, z is the atomic number. Then your R0 is what we call the Bohr radius. And Bohr radius is given, it has a constant. The constant is equivalent to 5.3 times 10 raised to the power minus 11 meters. So anywhere you see it, you can apply it. Alright? So that means your R becomes n squared. Now, what is your number of shell? You are having helium plus. Now, this positive sign suggests that helium is losing one electron. So normally the number of shell of helium, we have hydrogen helium, is supposed to be like this. Alright, so it's one number of shell. Alright, if there's no plus. But if there's positive sign, that means one electron is lost. So you now draw one. This one is for He, this one is for what? He what? He plus, that is helium. Now, if this He plus, alright, how many number of shells do you have here? That is 1. What is the atomic number of helium, which is Z here? That is 2. So you have over Z. So anywhere I see N now, I'm not going to brighten 1 squared over what is the value of Z? The value of Z is what? Is 2. Then everything into what? Into R1. Then I have R is equal to 1 squared is 1 over 2 all into what? All into R0. Then I have R is equal to this 0.5 multiplied by what? R0. Alright. Now what is the value of R0? If you want to go that way, 1 over 2 multiplied by, I said R0 is what? 5.0 multiplied by 10 raised to the power minus 11 meters. So you have radius of the atom to be 1 over 2 of that. So 5.3 should be 2 point whatever, I think 2.15. Alright, multiplied by 10 raised to the power what? Minus 11 what? Minus 11 meter. Alright, is it 0.15? Okay, so it's not 0.1. You can calculate that. Alright, you have 1 over 2 multiplied by 5.3 times 10 raised to the power minus 11. Okay, I think it should be 1.15 thereabout, or 2.0. No, it should be less than that. It should be around 1.7 something. So times 10 raised to the power minus 11. Of course, you know what to do. 1 over 2 multiplied by 5.3 times 10 raised to the power minus 11 will give you the correct answer for the radius of the atom. So that is how to calculate for the radius of any atom if you see it. Okay, that is one question on that. Now, but if you have to calculate the speed of an electron, alright, that is the radius of an atom. If you have to calculate the speed of an electron, how do you calculate for it? Now, this is for radius, this one is for energy. For the speed of an atom, what you are going to do, alright, is look at this. To calculate the speed of an atom. Now, from the first or the second theorem of Bohr, which says that there's a quantization and the angular momentum is quantized, which is NBR is equal to NH over what? Over 2 pi. We can look for the value of velocity or the speed here, alright, to determine, so that we can use it to determine the speed of what? Of an atom. So we have our electron. So I have NBR over what? We are looking for V, that's over MR is equal to NH over 2 pi. Alright, so we divide both sides by MR. So we have NVR over MR. R has gone, M has gone, is equal to NH over what? Over 2 pi, then divided by what? MR. So we have V is equal to what? NH over 2 pi divided by MR. Then we have V is equal to, so if all of this now, what's going to happen is that 2 pi will go up, right? So at the end we have what? V is equal to NH over what? Over 2 pi what? 2 pi MR. If you have to determine the speed of what? Of an electron, that's what you use to determine the speed. So this is for radius of what? Of an atom. This energy of an atom, what this one is what? It is speed of what? Of an electron. So take note of that if you are asked to calculate for any of those things. Alright, so let me take one question on energy. The question says that calculate the energy associated with the K shell of a helium atom. Now, we know that the progression is from n is equal to 1, 2, 3, alright, 4, 5, 6, and progressive to infinity. Okay, that is number of shell. Alright, now once we have known how to use our formulas to determine any question that they ask in that line. So if you are to determine the energy, I said your energy is equal to minus 13.6 EV, alright, maybe Z squared, sometimes over N squared, alright, because sometimes you have an atomic number. So unlike this question, unlike this question. No, that's this question. The question says that we should calculate the energy associated with the K shell of helium atom. So the progression is what? K, N, M, N. Alright, and I think the value is 2n squared, rising 2n squared, 2 raised to the power 2. So this one is 1, this 2, this 3, and this 4. So how many shell can K, alright, let's calculate the energy associated with the K shell of a helium atom. So how many can K occupy? K can occupy 1, so you have 2 into 1 squared. So you have 2 open brackets, 1 square is 1, that is equal to 2 times 1 is equal to 2. So that means, alright, the number of shell is going to give us what? 2. So you write it down using 2n squared. So if it's n, use 2n squared. If it's m, use that. So we have what? N is equal to what? 2. Okay, so what's the next thing? Helium of a helium atom. Then helium has which atomic number? The atomic number of helium, alright, is 2 as well, right? Because Z here is 2. So you have 2 here. So you have E is equal to minus 13.6 multiplied by, what is your Z square? That is what? That is 2 square EV, because there is Z square here, alright, divided by N square, that is under 2 square. Then you have E is equal to minus 13.6, alright, EV multiplied by 2 square is what? Is 4. This Z, alright, and Z is now what? It's not 2 square. So and N also is 2 square. That is 4. Z square, this Z square, which is now 2 square, because the value of Z was 2. Alright, Z was equal to 2. So we have Z square here, 2 square here, which is 4. Alright, over under 2 square, which is over under 4. Then E is equal to minus 13.6 EV multiplied by 4 over 4. Alright, so I think you cancel. So we have minus 13.6 EV, alright, multiplied by 4 divided by 4 will give us 1. That is E is equal to minus 13.46 EV. That's what you have as the energy of the of the K shell associated, alright, with a helium atom. So you have minus 13.6 EV. If you want to convert your answer to joules, alright, you multiply it by what? By 1.6 times 10 raised to power minus 19, because 1 electron volt is equivalent to 1.6 times 10 raised to power minus 19. So it is in electron volt. If you want to convert to joules, do minus 13.6 EV. Alright, so it's not an EV multiplied by 1.6 times 10 raised to power minus 19. Alright, whatever answer you have, it will give you in joules. Okay, so that's how to go about that. So I want to do the calculation. So we have 13.6 multiplied by what we have here, 1.6. So at the end we have, okay, let's do, we have 13.6 now say divided by 4. Okay, 13.6 divided by 4, we have 13.6 by 4, that's 3.4, then multiply by 1.6. Alright, so when you find the value, alright, whatever you have, you can write it, because the calculator I have here is not too functional. Okay, so that is how to go about, alright, your values. Now, what of the other ones? Now, for instance, if you are to determine kinetic energy of an electron, or the what is it called, or the potential energy of an electron, how do you go about that? So that's what I want to show you in another minute. How to determine the potential energy and the kinetic energy of an electron. Okay, this one is how to determine the energy. And if there's any question you have, you can do all to forward it, all right, to me. I'll do all to answer, to provide an answer to that. Okay, so now let's move straight away to the next part: kinetic energy and potential energy of an electron. So, if you are to determine the kinetic energy of an electron, all right, what are you supposed to do? Okay, so kinetic energy of an electron is given as, so Ke and what, and P, we can write it kinetic energy and potential energy of an electron. So now, if that is the case, now your K of an electron, all right, is given as Ze squared, all right, Ze squared. Z is the atomic number, then E there is the electronic charge. Okay, Ze squared over 8 pi E naught R. Z squared over 8 pi E naught R. This is how to determine the kinetic energy of what, of an electron. Z squared over 8 pi E naught R. So your Z is equal to atomic number, all right, atomic number. Then your E is equal to electronic charge. It is the electronic charge. All right. Then your E naught here. E naught is permittivity. All right. So your permittivity, E naught there is what we call permittivity of free space. Permittivity. Permittivity, E naught is equivalent to 8.85 multiplied by 10 raised to power 8.85 multiplied by 10 raised to power, I think, minus 12 farad. Okay, I think 12. Yeah, 10 raised to power 12 farad. Thereabout. So let me check that for you. E naught, yes, 8.85 times 10 raised to power minus 12 farad. That is the permittivity. Anywhere you see it. Okay, this kinetic energy. Then what is potential energy? Potential energy of an electron is given as minus Ze squared over 4 pi E naught R. The same thing. This one is 4, this one is 8. This one, there's negative, there's no negative here. This atomic number, electronic charge. Electronic charge is 1.6, or electron multiplied by 10 raised to power minus 19. So your E naught is the same, 8.85 times 10 raised to power minus 12. Alright, so that is how to go about that. Alright, so now the next thing we want to consider, right, is how to solve for ionization energy. Ionization energy is actually defined as the energy required to remove, all right, an electron from one energy level to infinity. I'll come again. Ionization energy is defined as the energy required to remove an electron from one energy level to infinity. So now your N is equal to infinity, and it has a value too. All right. So I've given kinetic energy, I've given potential energy. If you are to determine the ionization energy of any element, all right, of any atom, use this formula I'm about writing. Write your I dot E, all right, ionization energy is equal to Z squared, okay, Z squared E raised to power 4 M, all right, over, I'll show you what all of those things stand for. 8 E naught